All right, here we have a market for gasoline that looks a little bit unusual in so much as the supply of gasoline is not the marginal social cost of gasoline. And so this is indicative of the fact that there are some externalities in play here. So let's take a little bit of a look here. So our first question is asking us, what is the market equilibrium price and quantity? The market equilibrium price and quantity are not going to consider the externalities, and so are just simply going to be the intersection of supply and demand. So that's taking place at a price of $2 per gallon and a quantity of 9,000 gallons. Simply the intersection of the supply and the demand curve. Is this quantity socially optimal? No, it is not. Of course, the socially optimal is AP code for allocative efficiency. And allocative efficiency takes place when the marginal social cost equals the marginal social benefit. And we can see that these, the marginal social cost and marginal social benefit curves intersect at a quantity of 7,000 gallons. So we would say no, this is not allocatively efficient. The allocatively efficient quantity takes place at 7,000 gallons, where marginal social cost equals marginal social benefit. We could further say that because this market is producing 9,000 gallons when the allocatively efficient level is 7,000, that this market is over allocating. It is putting too many resources towards the production of gasoline. Well, what is it about gasoline that says that there are external costs associated with this? Well, we can see on the graph above that the marginal costs, the sum of the marginal costs, that's what the firms are incurring. That's their cost of producing gasoline. But the firms are not paying for the pollution that takes place, right? So the spillover costs here are going to be the pollution that occurs with this. So we can kind of take a look at this supply curve and this marginal social cost curve to point out that at any point along the supply curve, right here, let's say, that the marginal social cost of producing the 11,000th gallon of gasoline, the marginal private cost, the cost of the firms of producing the 11,000th gallon of gasoline, is about $2.50 for that gallon of gasoline. However, society incurs the cost of the pollution. So the vertical distance between the marginal private cost and the marginal social cost is going to be the amount of the externality here. That additional cost is paid for by society, though it is not paid for by the firm. And because of those lower costs seen by the firms, that's why they're going to tend to overproduce. So pollution is a good example of a negative externality, whether it is noise pollution, environmental pollution, any sort of pollution would be indicative of a negative externality. So the producers are not going to produce the allocatively efficient amount of gasoline because the costs they have to pay are lower than what the true costs of the production of the good are. And so firms have no incentive to reduce their production because consumers and producers can ignore that externality. They don't have to pay for it. That externality. They don't have to pay for it, and so therefore it does not enter the market consideration. Remembering that demand is that's the highest price people are willing to pay for the good. Supply is the lowest price producers are willing to sell the good for. And so since neither the producer nor the consumer are bearing the costs of the pollution, that is not going to enter into their calculus of how much of the price consideration for that pollution. All right. So number 5 is taking a look. If a government tax or subsidy, is a government tax or subsidy the most appropriate regulation of this market? Well, we've already indicated that they are overproducing, that this market is producing 9,000 gallons when the marginally social maximum or socially optimal level of output is going to be 7,000. If we want to reduce the production of this good, we're going to have to make it more expensive to do that. And so a per unit tax would be the most appropriate incentive to reduce production. And well, simultaneously, that reduction in production is going to raise prices and consumers will buy less. And so we can get to the allocatively efficient level by doing that. And what's interesting about these graphs is that we can see, well, exactly how much of a tax is necessary to compensate for the negative externality. So there's a temptation to say, oh, well, the price was $2 and the price is now $3, so we should have a $1 tax. That is actually incorrect. What we want to do is that we want to add to this marginal cost curve, the supply curve, a line that is going to coincide with the externality. And so if I can grab this, nope. Such that it comes up here. So if we can, what we're really doing is we're adding a vertical distance to make this new supply curve with the tax coincide with the marginal social cost curve. And so really what we're doing is we're looking at the vertical distance between the supply curve and the marginal social cost curve, the amount of the negative externality. And so in that case, that's going to be 25, 50 cents, 75 cents, $1, $1.25, $1.50. So this $1.50 tax will increase the marginal costs so that it coincides with the marginal social cost, and that is going to then result in the intersection of the supply curve with the tax and the original demand curve at the allocatively efficient quantity. And that's socially optimal. So that tax is going to have to be a $1.50 tax in this case per unit to raise marginal cost to coincide with the negative externality. Let's take a look at another example then. And here we can see that's slightly different here. In this market for COVID vaccines, we see that the supply curve does coincide with the marginal social cost, such that there is no difference between them. All of the costs incurred by the firm are the only costs that society incurs with this. That is to say, there are no spillover costs. However, what people are willing to pay for the curve, vaccine rather, is their demand curve represents their personal marginal benefits, but it doesn't represent the external benefits. That people that don't receive the vaccine, that don't pay for the vaccine, are still going to benefit from other people getting that vaccine. And so that external benefit is measured by the vertical distance between the demand curve and the marginal social benefit curve. So the analysis is somewhat similar then. Let's take a look. What is the market price for the COVID vaccine? Well, simply at this point, we have to take a look at the intersection of the supply curve and the demand curve, and that looks like that's intersecting at a price of $7 per unit and 8,000 units. So we're just looking, the market is always going to be at the intersection of supply and demand, what consumers and producers are willing to buy and sell for respectively. We can see that this is not socially optimal though, because we know social optimality or allocative efficiency takes place when marginal social cost equals marginal social benefit. So society actually wants 12,000 units of this good. So this is not allocatively efficient. And in fact, they're not producing enough. They are under allocating they're under allocating in this case. They're only producing 8,000 units when society actually wants 12,000 units. We've already answered question number 3. The spillover benefits are the benefits that people have from other people, that herd immunity that takes place because other people get the vaccine, even if you yourself do not pay for or receive a vaccine. Question number 4, I think, is a little bit obvious to this. Will a government subsidy increase or decrease the deadweight loss in this market? Well, if they are producing 8,000 goods and society wants 12,000 goods, a subsidy is going to increase their ability to produce this good. We want them to produce more of this good, and so therefore that's going to decrease the deadweight loss, right? So deadweight loss will decrease as it approaches the allocatively efficient output. So let's show what the deadweight loss was prior to the subsidy. As a reminder, deadweight loss is always going to be the area between the marginal social cost, the marginal social benefit for the goods that are being produced to the allocatively efficient level of output. So this shaded area here best represents the deadweight loss from under allocating the resources to the production of this vaccine. So let's take a look here at putting this all together. What conclusions can we draw about this? So we saw a difference between negative externality and a positive externality, and the biggest distinction, and we do need to be able to identify this, negative externalities can be shown when the marginal social cost is greater than the supply curve or the marginal cost curve, right? The sum of marginal cost. You can, of course, have negative externalities with a monopoly, so you do need to keep that in mind as well. So if the cost to society is greater than the sum of marginal cost, that's a negative externality, but positive externalities are going to be when the marginal social benefit is greater than the demand curve. So do not oversimplify things by saying, oh, whenever there's a negative externality, there should be a tax, or there's a positive externality, there should be a subsidy. Take a look at how many goods are being produced relative to the allocatively efficient level of output, such that if a market is over allocating resources, they're producing too many goods, then there should be a tax, right? So a per unit tax will reduce output. And just a word, as opposed to a lump sum tax would actually just be a change in the fixed costs, and as we know, changes in fixed costs do not affect marginal cost, therefore the intersection of marginal cost and marginal revenue will not change. So a per unit tax or a per unit subsidy is a better solution to the problem than a lump sum tax or a lump sum subsidy. I hope this is helpful. Please let me know if you have any questions. Thanks.